C2, coordinate geometry of the circle, GCSE recap. So in this first example here, we're using the information here, which states that the angles in a semicircle is a right angle. So that means that this angle here is 90 degrees. So from that, and the fact that angles in a triangle add up to 180 degrees, we can do 90 for the right angle plus 40, which will give us 130 degrees, and then subtract that from 180 degrees, the total number of angles in a triangle, will give us 50 degrees, which is our A. So A is equal to 50 degrees. Now the second one here is following the information we're given here, which says that a tangent is perpendicular to the radius through the point of contact, which means that this here and this here are both right angles, 90 degrees. The length of the tangents from an external point to the point of contact with the circle are equal, which means that this side and this side are completely equal to each other. So we're trying to find this angle here, B. We've got a quadrilateral, a four-sided shape, so we know that the angles are going to add up to 360 degrees. So if we do 90 plus another 90 for the two right angles, and then plus 70, which will give us 180 plus 70, which is 250 degrees, and then subtract that from the total number of angles in a quadrilateral, 360 minus 250 will give us 110 degrees, which means that B is equal to 110 degrees. Now this third one is very similar to the first one again. So we've got an angle in a semicircle, so we know that this one here is 90 degrees. But this is the centre of the circle, which means that this is the radius, this is the radius, and this is the radius as well. So all of these lines are equal to each other. That means that this is an isosceles triangle. So if this angle is 40 degrees, then this angle must also be 40 degrees because base angles in an isosceles triangle are equal. So this one will be 40 degrees as well. That means that this angle here at C will be 40 plus 40, which is 80, 180 minus 80 will give C equal to 100. So C is equal to 100. And again, this line here is straight. Angles on a straight line add up to 180 degrees. So 180 minus 100 will give this angle as being 80. So yet again, we've got another isosceles triangle because this is the radius and this is the radius. And base angles in isosceles triangles are equal because this is 80 degrees, 180 minus 80 is 100 yet again. And then we're going to divide that by 2 because 100 degrees is what these two angles are when they're added together, and because it's an isosceles triangle they are the same. So 100 divided by 2 will give us D equal to 50 degrees. In this one here, we've got a tangent and the radius, so we know that this angle here will be 90 degrees. We're already given that this is 75 degrees, so 90 minus 75 degrees will give us 15 degrees. So we've already figured out that E is equal to 15 degrees. And similarly to the last example here, because this side and this side are the same, we have an isosceles triangle, which means here this angle is also 15 degrees. Again, we have another isosceles triangle as well here, because this is also the radius. So if this angle here is 15 and this angle here is 15, that means that this angle at the centre will be 150. But we don't need to figure that out really, because here we have angles in a semicircle, which means that this is a right angle. We already know that this is 15 degrees because of the isosceles triangle made here. So that means that F will equal 90 minus 15, which equals 75 degrees.